Hey nerds, sorry I can't be with you here today. I'm on paternity leave with my son or daughter. I'm not sure which because it hasn't happened yet, but it will by the time you see this. Great, so I'm sorry I'm out, but the show must go on. So you guys will be going to check out simplifying expressions, making things simpler. And here we go. So at the top of your notes, you can go M9U6.2, simplifying expressions. And I'd like you to try the following as a warm-up. Get your brain thinking about how we add and multiply and write those things down. Cool? So pause me and go. Okay, so here we go. We want you to expand this, which is sort of like saying, all right, well, 3 times 4 is, I have 3 sets of 4, 1, 2 to 3. When we multiply, right, this should be 12, which is 4 added together 3 times, right? 4, 8, 12. So 4 times 2, you can think about as I have a bunch of 2's, 1, 2, 3, 4. I have 4 2's added up. You can think about it the other way around, but just for now, let's keep going with this, right? What's in parentheses is what we're using, and the thing in front is how many times we have those added together. That's what multiplication is. So here we have 2's, and the 4 in front means we have 4 of them added together, right? So 8. Ping, right? This really isn't the goal. Going from here to here will help us with simplifying expressions. This is sort of a little bit different. This is a bunch of 2's. It's 4 2's, but they're being multiplied. So we can't write it like this. If you're multiplying, that means adding, right? When you're multiplying, this is saying I have 2's being multiplied together 4 times, and that's how we write that. So similarly with this is I have k's added together. I know they're added because it's a multiplication, which seems odd, but this is the shorthand for writing k plus k plus k plus k 5 times. I have k's added together, 5 of them. This is the same sort of thing, where they're just being multiplied. And so the only difference is in the nomenclature tells you if you're using addition or subtraction or multiplication division. So therefore, this piece, this is like saying I have 2 sets of 3x, which means I have 3x plus 3x added up twice, right? And then if you break this apart, each one of these is, right, this is like if you kind of with your math goggles on put the x's in parentheses, this is sort of be like x plus x plus x, 3 of them. So this is this chunk, plus 3 more x plus x plus x put together, and if you add all those up, you get 6 of them. Yeah. So really, what we're going to be doing today is figuring out how to go from here to here efficiently, which you probably know or have some experience with that, just adding and subtracting. Yeah. So, can you tell me what 8 minus 3 is? No, I'm an adder. An adder is a type of snake, like a pit viper or a python. An adder. Oh, man. So, if you had any homework questions, go ahead and ask me now. Yeah, I know that one was a tough one. No, but, what you can do with them is break them down into their prime factorization, and then you can solve it that way. So, all right, great. Today, our learning outcomes, what I would like you to be able to do is simplify expressions by grouping like terms. We got to figure out what like terms are, and also to be able to distribute numbers into parentheses, monomials into parentheses. So let's get started. Simplifying expressions really deals with like terms, and like terms have the same pieces in their variables, right? So xy and -2 xy are like terms because they're both xy's. This is really like saying 1 xy, and this is -2 xy, right? this is the same sort of thing. 1x squared and 3x are unlike terms because this x and this x squared, the variables don't match up. They're not the same. So here's a couple examples. Here's a monomial. A monomial means it's a chunk of things being added or multiplied or divided, no addition, right? So monomial, there's only one thing in there. It's things put together with multiplication or division. So 3x and 14x are like terms, and it's because they have their variable sets are the same, right? This x and the x are the same. All right, so check this guy out. Ping. This is 16 xyz squared and negative 5 xyz squared, right? They're monomials. Everything's multiplied together. There's no addition or subtraction. But this piece, the variable set on the back, that's the same. So these are like terms, right? Even if they're uglier than this x and the x, they're still like terms. So these are unlike terms, right? 3x and 5y. Those are unlike terms because the variable pieces are not the same. And same thing here, right? I know it says z, but this is really 3z times z, right? So there's more z's here being multiplied, so the variables are different. They're slightly different, but they're different, right? So those are also unlike, yeah, because their variables are not the same. Cool? So like terms and unlike terms. Moving on. Okay, so to simplify expressions, an expression is like an equation. It just doesn't have an equals sign. So this is an expression, and we're just putting equal signs here to show the progress of our simplification. So in simplifying expressions, we're really trying to gather like terms. So 2a plus 3a, you can simplify because really you have a plus a, that's this piece, plus a plus a plus a, right? 3 more a's. And that's just 5 a's added up, so it becomes 5a. It's sort of like saying 2 apples and 3 apples is 5 apples. You can combine them because you're talking about apples. However, if you have unlike terms, a's and b's, you can't gather them because you're talking about 3 of these and 2 of those. So this is sort of like talking about 3 apples and 2 bananas. You just can't add them up and say I have 5 apples or 5 apple bananas or 5 banapples or whatever sort of crunched up word you want to put in there. So this you can't really combine them. So you just leave them. 3a plus 2b. That's as simple as we can get. Ka-ching! Leave it alone. Right? So take a second, try that one, and try that one. Pause me until you get them done. Go. All right. So when we're trying to simplify these, we're going to gather the like terms up. So here's a monomial with x and another monomial with x. And if you sort of look at them with your nerd goggles on, the x's are the same piece and the y is the odd man out. So really you have 7 x's, right? You got 5 here and 2 here, and so you have 7 x's, and then the 4 is left alone because there's nothing else to combine it with. Cool? We can do the same thing with this, with all this mess. If you look at it with your nerd goggles on, there are a's and b's. This is a's and b's and a squareds. So a squareds and a squareds. Maybe put those first. So we've got 7 a squareds. And then here's our set of, there's 4 a's and 7 a's there. So we end up having 11 a's. And left over we have 2 80s and 6 80s, and those are like terms, and so therefore we have 8 80s. Cool. So our simplified expression looks like this. Okay. And it's just easier to use. All right. Great. So we want to use the distributive property, and maybe you guys have seen this before. It's the idea that you can go 3 times x plus 2. I'll explain this in more depth in a second, but just you've probably seen this before, and you say, hey, I've got 3 x's and 6 regular numbers. And so we've taken this and sort of expanded this, right? So we're going to do that in a second. I want to show you that visually before we get there. So if you were looking at the area of a square, right, we're talking about this area, or a box, right? To find the area, you'd say length times width, so you'd say 2 times 5. And if you were looking at this area, you'd say 2 times 3. So you'd get 10 and 6. And then you just add up the areas, right? 16. Well, let's go 10 plus 6. 10 plus 6, 16. Fine. Another way to think about this is like this. You can say, all right, well, I've got these 2 boxes. Instead of multiplying twice, you could say, well, this area is, why does it do that? It always does that. And now I've got the spinny wheel of death. You can say this area is 2 times 5, this piece, plus 2 times 3, right? You go 2 times 5 and also 2 times 3. And you just add those up, right? Because this length is 5 plus 3 more. So you can call this thing 2 times 5 plus 2 times 3. Okay. That's easy with numbers. We're going to do it in a second with not numbers. So one way to think about it is like that. So let's do it with variables instead of numbers. It'll make it a little more applicable. So